So we know this is cosine because sine graphs start at the middle, come back to the middle, don't they? Sine graphs start middle, go high, go low, end in the middle. Whereas cosine graphs start high, finish high. They're like a big U shape. Or if they're upside down U, right? So this one's starting high. Meaning at the y-axis. I mean at 0. Where is he? At the y. Because you might think, oh, you mean start over here? No, I don't mean where they draw stuff. I mean at the y-axis. Where's his dot? High, at his peak. So that means he's a cosine. So it's a cosine graph. Okay, great. Yeah, we could have guessed that. They're all cosine answers. But I guess you could tell right away what the amplitude is, huh? What's the amplitude? Yeah. So, hey, forget that and just laugh at those, huh? Right? Those are big jokes. But we always have that none of the above. Don't you love it? None of the above is just always there to keep you honest about what you really know. All right. So, is it one of those two answers? How do you know? The problem with this graph, what makes this one especially challenging, is they're not giving us a whole period. They're just giving us like a little part of it, aren't they? That's what's hard. If they would have just given me like the whole U shape, then I could figure out the period and start finding some stuff. Well, think with me. Can I figure out what part of a whole period goes from here to here? Like this part is what part of a whole cosine period? Exactly. It's got to be a quarter. Let me show you. Let's go over here and draw a cosine. That's the trick you've got to realize. Well, there's two tricks. That's the first one. Just think about what cosine does. He starts high, goes down, goes low, comes back, finishes high. So in other words, he's in 4 even pieces. From high to 0 is his first quarter. 0 to low is his next quarter. It's like a basketball game or football game. It's in 4 quarters. Right? So from here to here is 1/4 of his whole story. 1/4 of a whole cycle, isn't it? So from here to here, whatever this is, and that's the other hard part, that's got to be 1/4 of the whole cycle. So if I can just find out what that is and multiply it by 4, I'll have one whole period, and then I can get the formula. Because I got to have a period. Because once I get the period, I'm going to use the period formula. 2 pi over b. You're going to have that on your sheet of notes, right? So I got to get the period first. To get the period, I got to find this point and multiply it by 4. Because it's 1/4 of a whole cycle. Right? From high to 0 to low, back to 0 to high. Okay. So you guys with me? Understand the big picture? I got to find this point and then multiply it by 4 because that's 1/4 of a whole period. Then I'll have a period. I'll plug it in. I'll solve for b. B is what goes next to x. Done. That's the game plan. Okay. So now, how do I find this point? What is that point? How do you find that? It's right here. How are we going to do that?
You can take 2 pi plus pi over 2.
Yeah, look what it's right in the middle of. Here's pi. Here's 2 pi. See how it's smack in the middle of pi and 2 pi? And how do you find the middle of two things? You average them. Add them and divide by 2. That's how we find the middle. Like you got a 70 and a 90 on a couple exams. What's your average? Add them and divide by 2. It's the middle. Right? So to find the middle of two things, we add them and divide by 2. So pi plus 2 pi all divided by 2. That's 3 pi over 2. That spot must be 3 pi over 2. Makes sense. 3 pi over 2, that's 1.5 pi. Of course. 1.5 is right in the middle of 1 and 2. Right in the middle of 1 pi and 2 pi is 1.5 pi. Of course. 3/2 pi. Good? So now what do I do with that 3/2 pi? 3/2 pi times 4. That'll be the period. Because remember, that's only the beginning of the cosine. That's only 1/4 of cosine's whole story. His whole one cycle, one period story. So multiply that by 4. That's 12 pi over 2. 6 pi must be the period of this cosine function. 6 pi must be the period of this cosine function. You tracking with me? So now I know the period. Bring it up here. 6 pi is the period. 2 pi over b. I can solve that formula for b now. It's a hard first problem. To solve for b, put this over 1, diagonal, diagonal. b times 6 pi is 1 times 2 pi. b times 6 pi is 2 pi. Last step, divide by 6 pi. What is b? Pi's canceled, 2 6. 1/3. b is 1/3. Remember the function is a cosine bx. The amplitude we already know is 5. Cosine, what's the b? 1/3 x. There it is.
How do we know if it's not like if cosine
Flipped upside down?
Yeah.
Because it would be an upside down u. It's starting high instead of starting low. So it can't be a negative in the front. If there's a negative in the front, it starts in the bottom. Does that make sense? So 2 important things to realize. The equation is a cosine bx, and the period is 2 pi over b. Those are the 2 equations you want to have on your sheet of notes for the final. That's what we used, right? But that wasn't enough. I had to work hard to find that period, didn't I? I had to find where they hit 0 and multiply that by 4. Then I had the period, and the rest came. So that's a pretty tricky question. We good there? All right. Try that one. So this is the second one, so I'll give you a couple of these. Notice both of these are work backwards, aren't they? I'm giving you the graph, work back to the equation. Remember I told you I think that's valuable? What do you think? First, let's do one cycle. Boom. I don't care about, I'm going to forget about all that. Just one cycle, right? Just focus in on one cycle. So is that sine or cosine? Sine. That's upside down sine. Right? Remember, sine always starts in the middle, goes high, goes low, ends in the middle. That's regular sine. But then negative sine, upside down, goes low first, then high, huh? So that's what we're talking about. That's a negative sine. He starts in the middle. He's not cosine. Cosine would start high, end high, or a negative cosine would start low, end low. You with me on those 4 basic game plans? So we know it's a negative sine graph, isn't it? So it's not that one. Of course, 3 of them are negative sines, so that's only a little bit helpful. So it's a negative sine graph. So it's all about finding the period, isn't it? It's all about the period. So where is that point where one cycle, one period ends? Can you tell me? So this is 9 pi right here. Is this 1, 2, 3, 4, 5, 6, 7, 8, 9? Yeah, so that's 6 pi, isn't it? That spot right there must be 6 pi. Right there. So the period, which is 2 pi over b, the period must be 6 pi. Is that good? Because that's the end of one cycle for sine. Sine starts in the middle, goes high, goes low, goes back to the middle. So here he is coming back to the middle after going low and high. That's the end of one cycle. It's 6 pi. That's the period. So now I can solve for b. Put this over 1. Diagonal, diagonal. 6 pi times b is 1 times 2 pi. Bring it over here. 6 pi, 6 pi times b is 2 pi last step. Divide by 6 pi. b is 1/3. b is 1/3. So this is y equals a sine bx. What's the 1/3? It's the one that's 1/3, so it's this one, isn't it? You okay with that? Like you can do that on the test, the final, in a week? So those are 2 questions from the new stuff, like I promised. 2 from the graphing. Make sure you have the period formula on your, and then this general, and maybe the look of sine and the look of cosine if you need to. It's whatever you need to. But I would be making that even right now on a separate piece of paper, right? Because we're doing the practice final right now. Anytime you need a formula, put it right there on your full sheet of notes for the final. Right, skip 4. Yeah, let's try this one. So that's a little tricky. So they want you to solve for x there. Go ahead. All right, so let me bring it over here. So 3 tan inverse 2x is pi. So we got to solve for x. So we just did a couple of these, right? So what do you do to get x alone? First step? Divide by 3. Boom. Tan inverse 2x pi over 3. Yeah, now what do you do to get rid of that tan inverse? Regular tangent. That's what we're talking about, right? Inverse function. So do regular tangent of the left and regular tangent of, not times, of the right. You're plugging them left and right into the tangent toaster. So tangent of both sides. These cancel. That's why we did it. So 2x is tangent pi over 3. Oh, that's not too bad. So now you just go to the unit circle, right? Let me grab the unit circle. I thought it was going to be a little more tricky. Tangent. There it is. So tangent pi over 3. So I want tangent pi over 3. Where's pi over 3? There. This is cosine, sine. Tangent is what? Sine over cosine. So that'll be root 3 over 2 over a half. So sine over cosine. Grab that, flip it up. Square root 3 over 2 times 2 over 1. Those cancel. Square root 3, huh? Tangent square root 3. So 2x is square root 3. Last step is divide by the 2. Square 3 over 2. Boom. That wasn't too bad. Is that okay? All right. Am I going too quick? You want to write that down? Let me mention, so here's what Tim was talking about. So I'm telling you where to find the stuff. So you can go find them on the YouTubes if I don't get through them all now. So numbers 5 through 9 are from practice exam 1. Find the YouTube. 10 through 15 are from practice exam 2, etc., etc. So you can go find them out there if you want them. All right, let's get back to the question. If I don't get moving here. So, all right, so one of the main things is the direction. Remember we talked about, is it going up, right, down, left, all that kind of stuff. So which way is this one going? Up and left. So up means positive in the front. Left means positive on, or negative on x. Remember that? Up, down is about the sign in the front.
But isn't going down 2 because it's negative 2, not positive 2?
Where's negative 2? No, I just mean which way is it headed, not where it started. It starts here, but which way is it headed towards? It's headed up and left. Yeah, so positive. So up and down is all about the sign in the front. Right and left is all about the sign right on the x, because x is right left. Remember that? Y effector's in the front, x effector's on x.
But isn't a normal root graph going the opposite way?
A normal root graph goes like this. So y equals square root, which means positive in the front, up, and positive on x, right.
And so wouldn't it have to be negative in the front because it's switched, it's flipped? It's going the opposite way than when it's going.
Okay, so if you put a negative in the front, that actually makes it go down.
Oh, okay.
Yeah, good question. Everybody with me on that? So things in the front are up-down effectors. They're y effectors. Whereas if you put the negative in there, then it goes left. Y'all with me? Remember that kind of stuff? Difference between an x effector and a y effector. That'll help you a lot in calculus, just to be able to look at an equation and know a lot about the graph that quick. So, okay. So this thing has to have a positive in the front and a negative on x. So this has a positive in the front and a negative on x. That's a good option. This one has a negative in the front. No way. B's out. It's got a negative in the front. It's got to have a positive in the front. This next one. Positive in the front. Good. Oh, but he doesn't have a negative on x. No way. See how quickly I can eliminate these? It's got to have a negative on x. That's what makes it go left. How about this one? Negative in the front. No, that would be down. You tracking with me? Maybe I can write it one other way. How about if I do this? If you have positive, that's up and right. How about that? If you go negative, positive, that's down and right. If you have negative, or what's that, positive, negative, that would be up and left. And if you have negative and negative, that would be down and left. Does that make sense about those signs? Sign in the front, sign on the X. Okay, so B, C, and D are out because of their misplaced signs. So it all comes down to it's either A or none of the above. Your favorite option. Sorry, I just enjoy torturing you. It's just a cruel part of my character. All right. So what do we do? How do we know if it's A or none of the above? Make a table. Remember how we learned to handle these by looking at the pluses and minuses, get rid of most of the options, and then at the very end, make a table. Remember how we learned to make a quick table? What do we do with that table? It's not just any old willy-nilly thing. We learned to plug in a certain X value. We learned to find the center. Remember how to find the center? So if the equation is really, I'm testing right now this equation, A. I'm testing A. Say, A, are you really the answer? So if I'm going to test this equation, what am I going to plug in for X? Been a while, been a couple months. Yes, plug in the X to make the X zone become 0. Remember, you plug in 0. You plug in whatever will make X's world 0. That'll give you the center dot automatically. So plug in 5. What do you get? If you put in a 5 right there, 5 minus 5, square root of 5 minus 5, square root of 0 minus 2. Minus 2, that means over 5 down 2 is the center. Is that dot? Yeah. That's over 5 down 2. Looking good so far. Now, what do you do for your next? One more plug-in. What do we always do? Either add one, or if that doesn't work, like it won't work here, subtract one. But suppose we didn't know that we just say add one. It's not going to work, which it shouldn't. This graph doesn't go to the right, does it? Let's see what happens. Plug in to that function. Five minus 6 minus 2. Plug in, what are we plugging in? Plugging in 6. 5 minus 6, that's the square root of negative 1. That's no, which is great. That you should grab the option. It's saying, no, I don't go to the right. I don't go over 6. That's exactly what he doesn't do. Instead, if you want to be triply sure, try subtracting 1 instead of adding 1. If you plug in 4, I'll go back, plug in 4. Y equals the square root of 5 minus 4 minus 2, square root of 1 minus 2, that's negative 1, over 4, down 1, right there, beautiful. It's all lining up. A is for sure the option. Do you see that? See how the table gives us confidence?